RCHUB International Foundation for Research and Education, and ISO certified.
We have lots and lots of things to be covered in today's session. So I hope you remember what I taught you yesterday. Yesterday, I have taught you about the SPSS, how to feed the questionnaire into the SPSS, what are the two types of data, based on the two types of data, how to select and statistical techniques. So these are the things I have taught you yesterday. So today we are going directly into the analysis part. So let me open. Yeah, students, in case, if at all, if you have any doubts, because we have many things to cover in a very small session. So I'm going to go as it is. In case, if at all, if you have any doubts, kindly note it down. At the end of the session, we will have the discussion and we will discuss at that point of time. Okay. So let me share my screen. So this is what we have seen. That is, in case if a two data are categorical nature, we can do only significant association test. When it comes to significant association test, it is only possible to do only either chi-square analysis or correspondence analysis using SPSS. Now, let me illustrate how to do this chi-square analysis or correspondence analysis and how to write an interpretation. So now, okay, so this is the questionnaire what we have seen yesterday. So what is the questionnaire? The questionnaire is related to training need analysis. So all these demographic questions, assessment of training needs, and everything is being incorporated. The performance gap, everything is incorporated into the questionnaire. You see, everything is incorporated into the questionnaire. So now we are going to perform an analysis. So first, let me start with the chi-square analysis. So for chi-square analysis, what is our very first condition? Both the data has to be categorical in nature. If both the data are categorical in nature, then only we can perform significant association test. This can be done by chi-square statistical technique. So let me see for what questions we can do the chi-square analysis. Yeah, you see. Let me do chi-square analysis for how frequently the training programs are organized in your organization with respect to education qualification. Because for PG graduates who are mostly in higher designation will be frequently getting training, whereas in the low level grade might not be getting frequent training. So let's see it like that. So the demographic question is A2 versus D4. So in order to do chi-square analysis, what you have to do is that, totally forgot. Is my voice audible, technical team?
Yes, it's audible.
Okay, okay. So click on the Analyze tab and then move on to Descriptive Statistics once again. Click on the Cross tab. So you will be getting this dialog box. In the dialog box, it will be asking you for which two categorical variables you wanted to do chi-square analysis. So I have to do for educational qualification and I have to do for this, how frequently, this A2. In case if you are viewing this question, if you wanted to view as a name, that is name here, D1, D2, just right click, display variable names. You may able to see only the variable names. So that is A2 against D4, right? So I'm going to select A2 into this column. So now what I'm going to do is that I'm going to click on the statistics. In the statistics, you have to check box the chi-square analysis, because if you click OK, you will be getting only cross tabulation. We are going to perform chi-square analysis. So click on the chi-square analysis. phi and camera value. This is a technique. This is a small technique to state how much association is there. Click continue, and in the cells, some guide may be asked, will be demanding you to show even the expected values, because chi-square analysis is all about observed value minus expected value, right? So if you want to show the expected value, check box it. Or if you don't want, generally when it comes to SPSS, we don't need to show the expected value. In case, if at all, if you want, check box expected value, click on continue. If at all, if you want any charts, click on the chart and then click OK. So let me repeat once again. So what you have to do is that first you need to click Analyze tab, go to Descriptive Statistics, click on the Cross tab. You will be getting this dialog box. Once this dialog box have appeared, select the two variables in the row or column. It can be vice versa also. So once the two variables are selected for which the chi-square analysis has to be done, make sure both the data are categorical. You see, this is categorical data and this is also categorical data. Both the data has to be categorical. You cannot choose a metric data here. You see, here this AA1, this is a metric data. I cannot choose metric data. Yet you will be getting the output, but it is statistically wrong. So you need to make sure both the data are categorical in nature and then select the statistics. Check box the chi-square and phi and Kramer's value. Click on the cells. If needed, you can click expected cell and check box the display chart in case if you want graph. And if you click OK, you will get the output. So how to write an interpretation for the output? To write an interpretation for the output, first what you have to see is the significance value. The significance value, the Pearson chi-square significance value. This is what is very, very important. You will be getting three important tables, ma. Three important tables. One is the cross tabulation. One is a cross tabulation having the original count against the expected count. So this is nothing but a cross tabulation with observed count and expected count. And in case if you're not check box expected count, you will be getting the original cross tabulation. Everyone please mute, ma. And second, what you will be getting is the chi-square test significance value. Here the important value is the Pearson chi-square value. And then the phi and Kramer's value. And then finally the bar chart. Generally, if you have not check box your bar chart, it won't appear. So you will be getting the three tables along with one graph. So how to write an interpretation? To write an interpretation, you have to look, as I stated, first you need to write the cross tabulation output. That is, you can say that among majority of the employees working in the IT company in Chennai, majority have UG qualification. You see, UG is 312 and PG is 124. And majority is having UG and in bracket you can write 312 and similarly followed by the PG graduates who is of 124 and only 26 employees have acquired a professional certification. And then you have to write that based on the cross tabulation, we can still say that most of the employees, the UG graduates receives the training sometimes gets the training for, and similarly for PG, it's almost frequently they get training. You see, as I stated, PG employees, PG graduates generally hold higher position and they get training frequently. And the professional, they never get training. Maybe they might be in a director position, so they won't be getting much training. So this is what is then cross tabulation output. First, you have to discuss about the cross tabulation one paragraph, and then you have to discuss about the chi-square significance value. So in the second paragraph, you have to write that the estimated significance value, now let me write it in a Word document for better understanding. Let me, yeah. So The most important thing, let me increase the font size. Yeah. So the significance value has to be less than 0.05 ma. 0.05 is nothing but the 5%, the 5% confidence interval or error that is accepted. So say for example, you are a judge. Say for example, Anandaraj. Anandaraj is a judge and I am a lawyer. So Anandaraj is telling me that you have, as a judge, he is telling me, as you are being a lawyer, you have to come with at least 5% evidence for a particular case. If you come with an evidence, at least 5% evidence, I will accept your case and we can go. Else, if you have less than 5% evidence, I will reject your case. So consider myself as a null hypothesis. So yeah, consider myself as a null hypothesis.
आप तो मेरा व्हाट्सएप शायद देखते ही नहीं है, मेरे को व्हाट्सएप पे आप देखते कहाँ हैं?
Please mute yourself, ma. So null hypothesis is nothing but if the value, let me put it as, yeah, let me put it in hierarchy. So if the null hypothesis is greater than 0.5, sorry, which is 5%, you have to accept. That is, as a lawyer, if I bring a case with more than 5% as an evidence, you have to accept me. In case, if I am bringing a case with less than 5%, you have to reject me. This is it, right? So this is where, this is how the entire significance value works. Yeah. So here, if you take a close look, ma, here in our interpretation, the significance value is 0.000, which is less than 0.05, which means we can write it as the estimated significance value is less than 0.05, meaning students, everyone mute yourself, ma. Meaning the null hypothesis is rejected, which means there is significant association between the variables, or we can say that there is significant association between educational level of the respondents. Priya, run, kindly mute yourself, ma. So there is a significant association between the education level of the respondents with the frequency of training. So this is how you have to write the interpretation. So in the first line, you have to state what is your estimated value. Is it greater than 0.05 or less than 0.05? This is generally for social science studies. For some cases, it might be 0.10, that is 10%. For some cases, it is 99% should be accepted. So it should be greater. So you need to consider like that. So the estimate, first you need to discuss the estimated significance value, and then you have to say that whether your null hypothesis is accepted or rejected, and then you have to write the sentence. There is significant association or there is no significant association. This is how you have to write an interpretation for chi-square analysis. So now let me move on to the next analysis, ma. That is, the next analysis is the correspondence analysis, which for once again, this has to be done for both the category. If both the variables are categorical in nature, for both the data are categorical in nature, you need to do correspondence analysis. But there is one particular condition here. So what is the condition is, both the categorical data has to have more than 2+ option. That is an important criteria. Say for example, if one of the question is yes or no, and another question is having more than 3 options, say for example, age group having 4+ options, here you cannot perform correspondence analysis because categorical variable 2 is only having yes or no option. Both the categorical variables should have more than 2+ options. Only then you can do correspondence analysis. So in order to do a correspondence analysis in SPSS, let us first check to which data we can do correspondence analysis. Yeah, same for the same question we can do. With respect to age, we will do. With respect to age, we have 5 options. And with respect to training needs, we have 5 options. So in order to do correspondence analysis, click on Analyze, go to Dimension Reduction. Under Dimension Reduction, you will be having correspondence analysis. So if you click, it will be asking for which row, what would you like to consider as a row, what would you like to consider as a column. So in the row, I'm going to select the age, and what is the other variable? A2, right? A2 as the column 2. Here it will be asking you define the range. The range should be 1 to 5 because we have 5 options, right? Similarly, this also have 5 options. So I'm going to put 1 to 5. And then I'm going to click continue and then going to click OK. The beauty of the correspondence analysis is that you no need to check box any graph. It automatically generates a graph, a scatter plot. We call it as scatter plot, and it automatically generates a cross tabulation. It automatically gives a chi-square analysis also. You see, this is the cross tabulation. You see, so this is a cross tabulation, and then this is the chi-square summary. You see here the significance value is 0.00, which means it is less than 0.05. And then what we have to discuss is the graph. You see, we have a great graphical representation, a scatter plot. This itself clearly states that between the age category of 20 to 25, 26 to 35, always or frequently or sometimes their training is carried out. Since they are new age people, frequent training is required. Whereas for 46 to 55, sometimes it is carried out. And 36 to 45, it is rarely carried out. Greater than 55, almost never, because they occupy the top end position, right? So the graphical representation is available. That is what is being implied in the cross tabulation. So in the summary here, now let me illustrate the illustrate the interpretation. So first, what you have to do in the interpretation, first we have to discuss about the cross tabulation. So in the cross tabulation, what you have to discuss, the majority of the IT employees considered for the study belongs to age category between 26 to 35 years. In bracket, you have to write 185, followed by 20 to 25 years, that is 146. And for the age category between 20 to 25, they frequently or always get the training, because they are low age people, right? They require training. Similarly, 26 to 35, they frequently or sometimes get the training. These two are highest number. Similarly, the 36 to 45, rarely gets the training or never gets the training. And 46 to 55, almost it's like frequently they get training. Greater than 55, it's like, sometimes they get training. So this, the cross tabulation once is been discussed in one paragraph. Then we have to discuss about the chi-square output. what is the chi-square output? 0.000, which means our significance value is less than 0.05. If it is less than 0.05, what first two lines will be? The estimated significance value is less than 0.05, meaning the null hypothesis is rejected. If the what if null hypothesis is rejected means what? Yeah, let me write it down. There is no significant association or relationship or influence, or we can say simply write it as impact or difference. Okay, but in case if it is less than, then there is significant impact or association or something like that. So first two lines is written like as it is. There is significant association between the age and the age of the respondents with the frequency of training. So this is what we can write. So now I hope you have understood how to perform the chi-square analysis and the correspondence analysis using SPSS and how to write an interpretation for the same. Don't mistype anything. So if both the data are categorical in nature, you have to do only significant association test. In order to do significant association test, through SPSS, you can either use chi-square statistics or the correspondence analysis. So to perform chi-square statistics, what you have to do, you have to go to analyze, then you need to click on the descriptive statistics cross tab, and then select the variables for which you need to perform chi-square statistics. In the statistics, click on the statistic tab, checkbox the chi-square, find Kramer's value. If you want chart, click and then click OK. In case if you want to do the correspondence analysis, click on Analyze tab, go to dimension reduction, correspondence analysis, and then you need to check in the correspondence analysis, you need to select the variables, and then if you click OK, you will be getting the output. So now let's move on to the next topic. What is our next topic? Yeah, significant relationship test. So let us go to significant relationship test. Many people even yesterday asked about how to perform significant relationship test. So in order to do significant relationship test, we need to make sure that our both the variables are metric in nature. What is metric in nature? Either both the data has to be a Likert scale based question or anything that deals with the numbers. Only then we can do the correlation analysis. So let us see where we can do correlation analysis in our SPSS data set. Yeah, we have factors, right? Yeah, very good. So we have factors like performance gap, organization analysis, task job analysis, person. These are categorical data. These are metric data. These are completely metric data. So yeah, let me once again check it in the data set. Yeah, you see, these are completely metric data. 4.6, 4.53. Okay. So I wanted to know, performance discrepancies and training need analysis are related to one another. So in order to do that, I'm going to click Analyze tab. I'm going to go to correlate. You see, in order to do correlation, you need to go to correlate and click on bivariate. So select the variables for which you need to perform, you need to do the correlation analysis. So here I'm going to do for PDA and TNA. It is not just limited to two variables. You can also do for three or more variables also. Let me do for another one variable, performance discrepancy and training need analysis, and yeah, task job analysis, JA. let us consider these three variables. I'm going to click on Pearson correlation. It is automatically checkboxed because correlation is frequently done for only metric data. There is something called a Spearman correlation, which can be done for a categorical based question, but it also has certain criteria that due to time constraint, let's see if there is a possibility. Correlation analysis in SPSS, what you have to do is that, let me repeat once again. Sorry, you have to click the Analyze tab, and then you need to click on the Correlate, bivariate correlation. Choose the variables. For example, here I'm using three variables. One is one is performance discrepancy, task job analysis, and training need analysis. And then if you click OK, you will be getting this output. How to write an interpretation for this output? To write an interpretation for this output, let me open the Word document side by side so that you may better able to understand. Okay. So, yeah. Okay. Yeah. Now we have got the output. First, as I stated before, you have to discuss about the significance value. What is the significance value here? Both the significance value, that is the performance. Let me see. I'm going to check only for training need analysis with respect to task and job on performance discrepancy. So here it's 866 and it's 0.829. So how to write? So we can write it as the estimator. Let me copy paste. The estimated significance value is less than 0.005 and meaning the null hypothesis is rejected. Therefore, there is significant relationship. If both the data are metric in nature, we need to do relationship test using correlation. There is significant relationship between what is that? Performance discrepancy and training need analysis. Performance discrepancy and training need analysis. We should not leave here. There is another thing we need to write. Then we need to write the R value. The estimated correlation value, the Pearson correlation value is 0.866. Note it down, ma. That is, if your correlation value is greater than 0.85, that is, it meaning 85% correlation. It has strong positive correlation if it's positive. In case if it is between 75 to 85, it has a significant correlation. If it is between somewhere around 50 to 65, we can say that it is weakly correlated. Below that, mostly you won't be getting the significance value. So we can say that the estimated Pearson correlation value is 0.866, meaning there is 86.6% relationship between, you can say that the 86.6% strong relationship between the performance discrepancy and training need analysis. So this is how you have to write the interpretation for the correlation analysis. Similarly, you need to write it down for task and job analysis. The estimated significance value is less than 0.05, meaning the null hypothesis is rejected. Therefore, there is significant relationship between task and job analysis with the training need analysis. Here, the estimated Pearson correlation value is 0.829, which meaning there is 82.9% strong positive. We need to write strong positive In case if there is negative value, we need to write it as strong negative relationship. If it is positive, we need to write it as strong positive relationship between the performance discrepancies and training need analysis. So this is how we have to write an interpretation. So now I also have discussed how to do the correlation analysis, that is how to do significant relationship test. So to do significant relationship test, both the data has to be metric. And then now let's move on to the significant impact test. So yesterday some person was asking me about trend analysis. I tell you, regression is a type of trend. Actually, from the trend, the regression has been derived, and regression is generally carried out for forecasting. Instead of me doing with this social science studies data, let me do it with secondary data itself, so that you may better able to understand the regression analysis. Yeah, regression analysis. Yeah. Okay, so this is the data what we have discussed yesterday, That is the EPIDA, the agriculture product export from India, that data it is. So now I'm going to do regression analysis. So in order to do regression analysis, that is, if you wanted to know if there is correlation, if there is strong correlation between both the variables, then we can go for significant relationship test. Relationship or significant impact or significant influence test, significant impact or influence test. For this also, both the data, for relationship, it is metric data, which means if you wanted to go further ahead to do forecasting, you can do regression analysis. In order to do regression analysis, what you have to do is that, you need to click, and this is not the data set. Click on analyze. Go to regression. In regression, actually, I tell you, there are different types of regression that you can check it in the curve estimation, but due to time constraint, I'm not going to focus on that. In SPSS, you can do different types of regression. Like you have learned about linear regression analysis, quadratic, compound, growth, logarithmic, cubic, sine, exponential, inverse, power. Logistics is categorical data regression, but I'm not going to focus on this. We don't have much time because I need to explain each and everything, but I wanted to teach you what this regression, how it works, and how to write an interpretation. So I'm going to focus only on linear regression, which is also one part of curve estimation. So we call it as linear trend analysis, as simple as this. Linear trend analysis, exponential trend. So I'm going to do linear analysis. I'm going to put, dependent variable as rupees, because based on how much quantity we export, the price is determined, right? So let me put a metric ton as an independent variable and price as a dependent variable, and then let me click OK. You see, I got the output. This output is not so good, not at all good, not at all acceptable. So, in reality, realistically, this is how you will be getting the output, but this is not acceptable. When it comes to regression, let me teach you first. When it comes to regression, you have to look at 4 important criteria. First, you have to look at the R value. The R value should be much greater in the sense the R square value should be greater than 0.6. The R square indicates the forecasting accuracy. So the R value should be greater than this. So in our case, our regression analysis, it's almost 1.156, which means we have our forecasting accuracy to be only only 15.6% accurate. Similarly, the significance value, this should be the second criteria. The first criteria is R square value should be greater than 0.6, that is 60% accuracy. And significance value should be less than 0.05, but here it's greater than 0.05, which is not at all acceptable. And the constant's coefficient, the coefficient significance value should also be less than 0.05. Here it is not so, which means this data set is useless for forecasting. Let me consider something else. Let me consider, yeah, the same linear regression, but with respect to year. Yeah, great. Super. Yeah. Now, with this, we can do trend analysis. I will show you. This is a great value. Okay. Here you see the R value is 0.918 and R square is 0.843. What I said, R square is the forecasting accuracy, which means our forecasting accuracy will be 0.84.3%. So I have done regression analysis, that is the metric tonnage, the export agriculture product export rupees with respect to year as an independent variable, time as an independent variable, because time cannot be controlled, right? Time as an independent variable. For this, significance value is 0.000, and even the coefficient significance value is 0.000. Now let me show you how to perform how to forecast using regression analysis. Is my all my screen visible, ma? Okay. So this is the data set we have. So this is the data set we have. Yeah. This is the data set we have, and this is the output we have derived. That is, this is the output we have derived. Yeah. Generally, we do trend analysis for to forecast whether it will go in a positive direction or negative direction. But regression analysis will exactly give you what will be the futuristic value. That's the beauty of the regression analysis. Many people think regression analysis is just an impact test or influence test. No, it's a forecasting test. Yeah. To So in order to do that, so in order to do regression analysis, what I'm going to do is equal to, here the regression formula is for linear is y equal to a plus bx. So a is nothing but the constant value, the beta coefficient here. So this one minus y equal to a plus bx plus b into, that is 587 point, this into this. So you see, I got the output. Let me make it as dollar symbol here so that it will be it will remain constant. You see? So during 2023, our export, agriculture product export will be of 11,690 crore rupees. Let me drag. So during the year 2024, it will increase further. And during the year 2028, it will be approximately 146297. So this is how. So let me show you the trend so that you may better able to understand. So trend analysis for this. Let me draw a trend line. Yeah. Let me show you the trend line also. You see the trend line is moving on. The trend line is moving on. So for this particular year, select the data. Yeah. Editors. Yeah. Now I got the trend line. And if you take a close look, if I move to this as per the trend line, if I move to 2023, it will be somewhere around 1160. You see, it's already in 10,000. It's already in 11,000 something. Let me increase. So this is how the trend lines move. And let me show you the projection also, equal to trend. You have a formula to do trend analysis in Excel. So let me consider the data. No of y's. No of y's is nothing but these values. Comma, no of x is nothing but these values. The new x is nothing but this value. And then I'm going to click OK. You see, both the values are same. So in Excel, the trend analysis is in general is a linear trend analysis. So the regression estimates using linear trend analysis is producing the same output, you see, which means the linear regression and linear trend analysis are same. So if you're going for different trend analysis, say for example exponential, or say for example logarithmics, like that, it varies because the formula varies. So now I hope now you understood that the regression analysis is generally carried out not just to find whether one variable is influencing the other variable, but also to identify or also to forecast the futuristic value. So it is for this the regression analysis is done. So now let me move on to the next test, that is oh my God, significant difference test. This is also big. So in order to do regression analysis, what you have to do, you need to click analyze, go to regression, click on the linear, select the variable, select the dependent and independent variable, choose the dependent and independent variable wisely, because you should know whether which variable depends on another variable, and then click OK. Okay. So moving on to the significant difference test. In order to do the significance difference test, the first and foremost thing is that one should be categorical data and another should be a metric data. Only then you can do the significant difference test, or else you cannot do the significance difference test. So let us consider this data set itself. We have categorical data, demographic questions as a categorical data. Is there any metric data? Yeah, you see competencies. In the questionnaire, for competencies, where it is, career opportunity, drivers for conducting training. We have 4 options. These are Likert scale based question, right? That is AA1 to AA4. I wanted to know, is there any significant difference with respect to gender on the opinion for drivers for conducting the training? So in order to do that, what I have to do there, I need to go to compare me. I need to click in case, make sure we have 2 things. One is independent sample t-test and ANOVA test. Independent sample t-test can be done only for the categorical question which has only 2 options, which is having only 2 options. Say for example, we have only 2 options here, male and female. For this, you can do only independent sample t-test. In case if you have more than 2 plus options, for this also only 2 option is there. Education or qualification, we have more than 2 plus options. Okay. So in order to do independent sample t-test, let me come. So for gender and drivers for conducting the training, I'm going to do independent sample t-test because the gender has only 2 options. You see, in order to do independent sample t-test, no, let me do the ANOVA test first because it is easy for interpretation. So let me go to compare me. Let me go to one-way ANOVA. Let me select education qualification. It has 3 options, right, as a factor. And yeah, this AA1, AA2, AA3, AA4, this as my drivers for conducting the training, which is Likert scale based question, as my dependent variable. Now I'm going to click OK. So for ANOVA test, I will be getting this output. So in ANOVA test, you will be getting the significance value. You see the significance value is 0.000, which means, oh my God, we need to do the post hoc test. Okay, so what I have said, we need to check, in order to check the null hypothesis, in order to check the null hypothesis, what you have to do, you need to check the significance value. If the significance value is less than 0.05, it is less than 0.05 for all the case, which means less than 0.05, which means there is significant difference in opinion with respect to education qualification for the drivers for conducting the for the training. So if they have been asked with respect to UG graduates, with respect to PG graduates, and one who acquired professional degree, they have been asked, what is the cost for giving training? What is the driver for conducting the training? And their opinion is completely different. So for this, in case if at all, if you come across these kind of situation, you need to do the post hoc test. This you can do by going to compare mean, select the variables, that is the education level as an independent variable, and competencies. You can also go for Duncan and Turkey test, but I don't just, you cannot specifically say what are the exact things that, you see, now I got the output. For UG graduates, majority of them say what is the highest value. Timely completion of the project, they are being given training, followed by career opportunity and growth organization. And for PG graduate, what is the highest mean score? The highest mean score is for this one, the timely completion of project. First is for growth of the organization because they hold management position, right? Followed by this timely completion of the project. And for professionals, it is growth of the organization. So it varies, the rank varies. So for this, you need to perform rank analysis. So this is how you have to write an interpretation for ANOVA test. You need to do the ANOVA test by clicking the analyze, going to the compare mean, and then you need to click one way ANOVA, select the variables, and you need to check for the significance value. If the significance value is less than 0.05, then you need to write it as the estimated significance value is less than 0.05, meaning the null hypothesis is rejected. There is significant difference in opinion between the between the respondents having different level of education with the drivers for conducting the training. So this is how you need to write an interpretation. And since there is significant difference in opinion, they will be asking what is a significant difference. In order to show that, you need to go for post hoc. Mean rank is more than enough. So then let me go for independent sample t-test. So I told you, right, in order to do independent sample t-test, you need to have only two categorical data. So to do that, you need to go for compare mean. Where is that? Compare mean, independent sample t-test, select the group. I'm going to do for gender, right? I'm going to do for gender. It has only two options. And generally independent sample t-test, it will be asking you to define the groups. Say for example, even if you have three options, you can select only two groups. I told you, right? Independent sample t-test means you can select only two groups. So I'm going to select one as male, two as female. Only two groups are there already. So I'm going to click continue and click OK. Now I got the output. Oh, what is this? Okay. So now I got the output. Here I will be getting the descriptive statistics as well as output. But if you take a close look, here you will be having three significance value. Here where the confusion comes. That's why I have done this independent sample t-test at last. So here you have three significance value, one significance value here and two significance value here. Now you may have a question. Sir, which significance value do I need to consider? So here also the same criteria can be applied. You see, the what is the criteria? If it is greater than 0.05, you need to accept, right? You need to accept. Here it is less than 0.05. The first significance value is less than 0.05, which means you need to reject the significance value completely straight to it, and you need to accept the significance value at the bottom. So this is what you need to accept. Let me consider, yeah, if you see here, the significance value is greater than 0.05. You need to accept the significance value 0.231. So this is how, yeah, this is the best example, and reject this one. So this is how you need to accept and reject the null hypothesis based on this first significance value. So here also, if you take a close look, yeah, other than this, all items significance value are less than 0.05, which means we can write it as the estimated significance value is less than 0.05 for career opportunity, timely completion of project, and growth of the organization, meaning the null hypothesis is rejected. There is significant difference in opinion of the male and female respondents. But for the change in environment, there is no significant difference in opinion, because you see the significance value is greater than 0.05. So this is all for the demo. You can also do one sample t-test. The one sample t-test, the criteria is that you need to have a standard value. That is, I told you, right? Say for example, if you are running a service showroom, you have 10 vehicles, 10 vehicles, and you know the mileage given by the company is 42. So test value will be the standard value, the 42. And if you click OK, you will be getting the output. The same significance value, you will be getting it. So today I have taught you significant association test. If two data are categorical, you need to do significant association. This you can do by chi-square or correspondence analysis. Similarly, I have taught you correlation analysis. That is, if both the data are metric, you need to do significant correlation analysis. And in case if there is significant relationship between one another in correlation analysis, you can go. Yeah, Akshay Kumar, he have asked to explain about F value. I tell you, Ma, when it comes to SPSS, you have to focus not on T value or F value or the degree of freedom, because end of the day, after calculating the F value and the degree of freedom, you will be getting the significance value. It is a significance value that is very, very important with respect to SPSS, not the T and F value, because if you are going on a manual way, you need to check on the book, the log book, and then you need to check whether if everything falls into the criteria. But here in SPSS, you will be looking only at the significance value. So don't focus on degree of freedom or the F value here. Okay, this is my humble suggestion, because I see some of the researchers are still writing the F value, because after writing the significance value, why, when I could see the significance value, why do I need to know about the degree of freedom or F value? Yeah, of course, I wanted to cross verify. In order to cross verify, I may require the two values, whether they are right, if it is significant or not. But actually speaking, this F value and T values are not much concern with respect to SPSS. So it's not just T value, F value, that is for ANOVA. You will also go get some other values like T value for with respect to some other different types of test. Okay, anyone, any other questions, ma? So was the session clear? Students? So I think
Yes, sir.
everything.
Yes, sir. Yes, sir.
Okay, ma. So in case, if at all, if you have any doubts, but maybe in near future, let us plan for some more days to add for SPSS, so that I'm able to better teach you the different kind of analysis like cluster, that is exploratory factor analysis, the non-parametric tests, and other some optimal scaling analysis, because these all together makes the SPSS, and we can also drag some time so for better understanding. Okay, so with
Sir,
the
I have a question.
yeah, please, ma'am.
Sir, like very basic analysis, like as you said, the descriptive analysis, or further going ahead with regression, correlation, all those things can be done with SPSS.
Yes,
Okay,
ma'am.
and I think SPSS is sufficient enough to do the factor analysis also.
Yes, ma. We have option to do a factor analysis
Yes.
also, ma.
So, but for doing CFA or the advanced
Yeah,
analysis, like
that you cannot
structure
do
equation
using.
modeling.
Yeah, that you cannot do using.
Yes. So for that, AMOS is required.
AMOS is required. Yes, ma. We also have various plugins to make things very clear. I will show you. I will show you because you may better able to understand. I hope my entire screen is visible. Is my entire screen visible? No, right?
Yes, sir. Yes, sir.
So, yeah. This is the confirmatory factor analysis. If you are going to do this confirmatory factor analysis all by yourself, drawing this latent way, all these variables and all these factors, having so many variables, you may get into clumsy things. We have various plugins right now. You see, plugins to draw covariance, plugins to do master validity test, model fitness, and to draw the pattern matrix builder. To know the standardized armor, there are various plugins. See, this SPSS have one important constraint, that is, after exploring the factor, you cannot confirm whether your factor is reliable or not. It is for that the AMOS is being built to know whether the factors are reliable. For the futuristic analysis, you go for CFA. Once you have identified all your factors are reliable, they have having the convergent and divergent validity, you go for structural equation modeling. And if structural equation modeling is good, you can also go for it's like we call as something. I totally forgot the technical term. That is two model is I think there will be two factors and two factors relating to one other. Moving on to, it's not a mediating variable. It's something I forgot the technical term, but in case if I've got an opportunity, I will teach you, ma. Okay. So anyone, any other question? And not just our SPSS and AMOS, even SPSS and AMOS have a constraint. It is for that eViews has been created. In order to do with secondary data, generally we cannot do a normal, yeah, we here using SPSS, you can do normality test, but you cannot do the first difference, second difference. It is for that eViews has been created, generally to deal with the secondary data.
Yes.
Okay, ma.
Okay, thank you so much for the wonderful session, sir. It was very insightful, and since you have shown everything on a practical virtual way, so it's really going to help us a lot. Thank you so much.
Ma. Okay, ma. Anyone, any other question, ma? Chat box. Okay, so can you wind up? So thank you all. Thank you, God. See you all.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.